Hyperloop obviously is a very difficult engineering challenge to accomplish, and you can see numerous different ways these teams have tried to implement it over this past year or so in competition. Now, for us to actually accept the team to get into the final Hyperloop testing chamber for this runs that you've seen throughout the day so far today, the teams have had to accomplish a number of different milestones, 10 in fact, to fully complete the competition. The first of these milestones the teams actually went through was a safety briefing. The teams came back on SpaceX property about a week ago, and they met with our SpaceX advisors. We partnered SpaceX advisors directly with those teams to basically run down any damaging, any concerns, hazardous parts of their pods, and make sure that the students were going to be operating them safely, and everyone else would actually be behaving safely in the operations of the tube and also during all the testing. Again, testing is the emphasis here. These are test runs. This is a competition, but ultimately they are testing a scaled version of the final Hyperloop design. After these teams go through the safety briefing, they move on to a structural inspection. The real goal there being to assess the structural integrity of the pod and also look into the vehicle's braking systems and fasteners. Make sure the joints are some of the most riskiest elements, so the areas where components often break. So we want to verify that the joints are especially taken care of. After you get a structural inspection, you know that the vehicle itself is sound. You move into a functional check. That's where you start bringing in all the electronics. In spaceships, that's like our avionics. For these pods, they have all the electronics across them with the flight computers, taking in all the different sensors and telemetry and making sure that those are all well and good and functioning, and verifying, especially that their communication systems are working, that they're going to be able to go into the pod and successfully navigate the length of the course, you know where it's going, not inadvertently brake, etc. After they do a functional check, or maybe in parallel, some of these tests can be done out of order. It depends on how the team is ready. And it is possible that they could complete the functional check, but have to do some fixes on the structural inspection as they go through in testing. And some teams did have instances like this through their testing process. The mechanical fit check is another test they went through after the functional test. Mechanical fit check, really just looking to make sure that the pod can fit along the track. We then would bring them into the vacuum chamber. The vacuum chamber, probably one of the more challenging tests that they have to do here. Working in a vacuum is very difficult. So we bring the pods into that vacuum chamber. It looks just like you're seeing on there. It's kind of a small section of the larger Hyperloop test track. It has the same interface at the base. It has the same wireless communication system, similar lighting setup. So the teams can basically verify that electrically everything will work in that vacuum environment before they actually run inside a full-on chamber. From a vacuum chamber test, we're also going to perform a navigation test. A little bit different than any of these other ones in that we're typically focused on the sensors of the craft themselves. Are they going to know where they're at, or the positions? If you've been following us throughout the day, you've heard that some teams use encoders along the wheel. That was Lehigh University of Maryland. They simply are counting the optical track and then using velocity measurements, the optical strips on the inside of the tube, that is, and then using velocity measurements to determine the position. So we're verifying that code works and that they're doing proper calculations there. And then there's also something called navigational drift. It's not uncommon for sensors to drift as they're going through, as they're just being steady state, sitting there. We want to make sure that over a 5-minute period that the position doesn't change. It doesn't think that your pod has moved forward 10 feet, even though the pod has remained stationary. So we're verifying those kinds of things as well. Coupling all these together, really your navigation and your functional together, is the state diagram test. That is the software systems check. And that basically is ensuring that from the software perspective, all of these different systems are going to function together, specifically the logic involved with it. Interdisciplinary project, that's what Hyperloop is. So you need both your mechanical engineers to cover the primary structure and the structural inspections to get by that. You need your electrical engineers to bring the vehicle together and get the power systems going. You need your software engineers to write the proper software code and get the state diagrams and really flesh it out, so that way the vehicle is going to do emergency stopping properly, or that it won't inadvertently break if something happens. From the state diagram test, once we know that the vehicle itself is effectively sound, that these capsules and pods can guide on their own and they're not going to be hassling on things, we're going to do an external subtract test. That's just near the testing lot, adjacent to the vacuum test. The teams there will bring their car or their pod directly onto the track there. It's about a 150-foot section. We'll accelerate them to about 15, 20 miles an hour, or we accelerated them to that time. And all these teams pass that track test. The pod will get pushed by a pusher, SpaceX system. It will release them. They'll brake, and they'll verify that everything is functioning there properly. From the external subtrack tests, the precursor to the testing you've been seeing today was the open air Hyperloop Run. Every team does one run in the open air, not depressurized, everything like that. We make them do it that way because the depressurization takes a long time, as you probably have seen today. So a lot of teams have done the open air runs, which brings us to the Hyperloop Runs, the final milestone run, which is extremely exciting. We're almost done with one of the pump downs. You may be hearing over the PA right now. But as that pump down is going on, we all know that it's a challenging effort. It's a big tube, so Brian's got a little bit more information on depressurizing, working in a vacuum, and this tube itself.
Right, so I'm standing next to the tube, and as you heard in the Hyperloop 101 video earlier that Steve Davis presented, the design of the Hyperloop test track here right next to our headquarters was really meant to not constrain any of these student teams. We wanted to make sure that they were at liberty to use any discipline and any resource they could, including the magnetic levitation, air bearings, wheels, whatever means they wanted, we wanted to accommodate. And as such, we built this tube to be quite variable. It has aluminum plates on its bottom. We call that the subtrack, and that's used for magnetic levitation so that the pods can suspend themselves if they choose. It has an I-beam in the center, and although that may not be in the final design for any commercial Hyperloop transportation cells, it's there for guidance for these student teams to make things easier, as well as provide friction braking, use it as an air bearing, anything they want. We don't want to constrain them. There are also light strips placed along the roof every so often within the inside of the tube, so that teams can use those for navigation to know where they are, how far they're going, how fast they're going, etc., because they are at predetermined spacings. There's also camera inside. You can see those 8 different paneled cameras in the webcast. If you've been following along today, those are keeping up with the action. That's a bit about the tube itself. Now, it's placed just next to our headquarters, and it doesn't actually quite span the entire length of the road that it's on. Fun fact, we actually left it, it's just under a mile long, but we left it not continuing to the very end of this road so that we could keep room for our rockets to leave the SpaceX production facility. So that's a bit of a gem that was a curveball as we designed this test track right next to our facility. Now, we've had a